Assalamualaikum. Today, we like to present our lab 2 of electrical electromagnetic magnetism, which is investigation the effect of electromagnetic interference due to conducted emission. The introduction of this lab report is electromagnetic interference AMI occurs when unwanted signal disturb electrical system. Next one is two type tested in this lab, which is radiated emission through air and the conducted emission through cable or body. The third one is spark discharge and human ESP are used as EMI sources. Next is objective. The first one is to observe radiated EMI produced by spark discharge to measure conducted EMI caused by human electrostatic discharge ESD. The third one is to study how distance and conditions affect EMI strength. The next one is equipment use. The equipment that we use in this lab is the first one is obviously oscilloscope, which is oscilloscope Tektronix TDS 201C digital storage oscilloscope. The second one is flat plate antenna packing with ground cable. The third one is cable, coaxial cable. The third one is T-junction. The fourth one is 40 kV ignition coil electric spark discharge radiated sources.
Okay, now I will explain about radiated emission. First, EMI that travel through air from a spark or electronic device. Second, measure using an antenna connected to the oscilloscope. Third, amplitude decrease as distance increases. For the effect can interfere with nearby electronics, produce high frequency pulse and noise, and lastly causes unstable readings or malfunction in sensitive device.
Okay, for conducted emission, first EMI that flow through cable or conductive path, including the human body ESD. Second, occurs when static charge is released into a system, measured by touching the antenna after warming up. The effect is it can cause voltage spikes on circuit, can damage components or disrupt performance, and create harmonics and noise on power lines.
Next, I will explain to you and teach you how to set up for radiated emission. The first step is open trigger menu. What you have to do is start by pressing the trigger menu button on the front panel to access the trigger setting. After that, you will set mode and coupling. You can change the mode to normal and set the coupling to AC because this lab we're using the AC system. The third one is adjust channel 1 setting, which is you have to press the channel 1 button, menu button, and you set the vote division 1 vote. The next one is you have also set the trigger level. Turn the trigger level knob to match the scale, which is you set 1 vote also.
Okay, to setting 30 volt on oscilloscope, first we need to set the oscilloscope at channel 1. Second step, switch the volt per division in fine mode. Then we go to the probe and switch the attenuation to 10 times. Then we change the voltage scale channel 1 to 30 volt. Then we get the 30 volt setting for the oscilloscope.
Assalamualaikum. My name is Amar bin ZAIRI. I will explain about the correction that we have after the presentation with Dr. Zikri. So, from the result obtained, the highest pulse amplitude decreases significantly as the distance increases from 61.2 volt at 4 cm to 14.4 volt at 20 cm. This tend This trend clearly indicates attenuation of the radiated emission with increasing the distance. Although the voltage and time division were kept constant, which is 30 volt per division and 50 microsecond per division, variations in rise time and pulse duration were observed, showing that the distance affects not only the signal strength but also the pulse characteristics. Therefore, the experiment data confirms that radiated emission strength reduces with distance from the radiation source. So next, this is the result that we get from 4 cm. So the left one is from the MATLAB, and then the right one is from the digital oscilloscope. So I will explain one by one how to collect the data. So the first one is rising time, which is we take the first pulse, the beginning of the pulse, which is 0 volt, until the highest amplitude, and then we have a zero crossing. We take the first 0 volt until they are turning back to 0 volt, and then overall pulse duration, which is from the beginning of the pulse until the end of the pulse. And then the last one is half full width. We take the highest amplitude, and then the 50% of the amplitude, we take the duration of it.
Okay, now I will explain about conductor emission result. So for this slide, show the conductor emission result measured using an oscilloscope for different participants. So we have 8 participants. For all measurements were taken under the same setting, which is 1 volt per division and 100 millisecond time over volt division. So for this, we analyze key signal parameters like rising time, overall pulse duration, the highest amplitude, zero crossing, and also half full width. So from the result, we can see the variations in pulse behavior among individuals, especially in rising time and peak amplitude. For the highest voltage, we got 5.08 volt, and the um, minimum voltage, we got 1.96 volt. So this is the simulation result for Izzuddin. For the weight is 80 kg and height is 178 centimeter. So this is the simulation result from MATLAB and also oscilloscope. So for the rising time, we got 4.8 millisecond and high amplitude 1.96 volt, zero crossing 138.0 millisecond. Alright, for this slide shown the simulation result for Amar, which is the lightest one, 53 kg and 172 centimeter. So for the rising time, we got 17.2 millisecond, high amplitude 2.56 volt, 170.4 millisecond zero crossing, and also 149.6 millisecond pulse duration. Next, this is the comparison between the heaviest student and also the lightest student. So for this slide, compare the conductor emission results. So I take the heaviest 80 kg and also 53 kg. For the heaviest subject shows a faster rising time, lower amplitude and no shorter pulse duration, which indicates lower body impedance and better signal conduction. For contrast, the lighter subject has a slower rising time but higher amplitude and also wider pulse duration due to higher impedance, causing more signal reflection. So for overall data, the differences in body composition such as muscle mass, water content, and tissue conductivity explain the variation in signal behavior. That's all. So lastly, the conclusion for in this lab, EMI was observed through radiator and conductor emissions experiments. Radiator emissions showed that signal strength decreased with distance, while conductor emissions demonstrate that human electrostatic discharge can create voltage spikes affecting circuit. The lab highlight EMI behavior, the importance of proper oscilloscope settings, and the need for good EMC practice. Thank you.